Hello everyone, welcome to Ganit. Today, as discussed in the previous video, we were solving some questions on midpoint and intercept theorem. So this is our next question which we are going to talk about. It's a quite popular question, to be honest, almost present in every textbook where midpoint theorem has been done. So in the question we have ABCD is a parallelogram. So parallelogram is a relevant information. It will help us in while we are decoding the question. Parallelogram. It also says E is the midpoint of CD. That means this is equals to this part. And through D, a line is drawn parallel to EB to meet CB produced at G, intersecting AB at F. Okay. So after that, it's just a question. The two things that we know from reading this much is AD and BC will be equal to each other. AB and CD will be equal to each other, right? Why is this happening? Because opposite sides of parallelogram are equal. All right, now let's move to the question. The first part is saying AD is equals to half of GC. Let's spot where is AD. AD is here. Okay. Please understand, I have a midpoint and a set of parallel lines. What does that tell me? I think by now you have guessed because I have so many times repeated this sentence that by now you would have gotten almost frustrated, and at the same time you would have learned what this trick is really. So I'm going to spot the triangle first and then spot one midpoint theorem, one midpoint and a set of parallel lines. So first job is to write the correct triangle. If you don't choose the right triangle, it will be a problem. So triangle CDG. In triangle CDG, E is a midpoint. It's given to me. And EB is parallel to DG. So by converse of MPD, what do we get? We have B as the midpoint of GC. I'm just using converse of midpoint theorem, good old fashioned converse of midpoint theorem. Okay. Now, if B becomes the midpoint of GC, that means this BC is actually equals to BG as well, right? So I can say that BC is equals to half of CG. But guess what BC is equals to? AD, opposite sides of parallelogram. So I can say therefore AD is also equals to half of CG. That's the first part of the question. Hence proved. Writing hence proved has to be one of the best feelings in the world, isn't it? It's so satisfactory, right? So let's move to the next part of the question. It says DG is equals to 2EB is what we have to prove. So DG and EB. Now it's okay. I mean, from here, I think it's just midpoint theorem will take over. So what we have is in triangle, again, CDG, we can say that B and E are the midpoints, right? So if B and E are the midpoints, what does that tell us? That BE is equals to half of DG. So if I transfer the 2 that side, it becomes 2 times BE is equals to DG. And I can write hence proved. So this was relatively a simple question as compared to the ones we have done before. I hope you have understood every step that I took here. Let's move to the next question, please. Okay, so this one looks nice. So in the adjoining figure ABC, AD is the median. Guys, median, as I had told you in my explanation video, median is an indirect way of putting a midpoint into the mix of the question. Okay, please remember that median means AD is a median means that BD and DC are equal and D is a midpoint. So median AD is a median, that means that D is a midpoint. Knowing the hidden meaning behind the information given to you is one of the very, very important skills to have in mathematics. So they are saying AD is median, but you're not looking at AD being a median. What you are looking at is D being a midpoint because that's relevant to us. We use midpoint in midpoint theorem and converse of midpoint theorem. We don't care about median, right? So pluck out the relevant information from what is given to you in the question. You need to know that, okay? So AD is a median. All right. Now I'm going to work with triangle ADG. All right. So triangle ADG, if you see there, E has been given as a midpoint. If you read the question, they are saying E is the midpoint of AD, right? And I also have DG parallel to BF. So one midpoint and a set of parallel lines. What does that bring? Converse of midpoint theorem. So in triangle ADG, E is a midpoint. That's given to us. So I can say also EF is parallel to DG. So I can say that by converse of MPT, F becomes midpoint of AG. That means I can say that this is equals to this, right? Now I have to spot another triangle where midpoint is mentioned. I hope you all remember that D is a midpoint of what? BC. So BC could be the side of the triangle that we are going to look forward to. So the triangle that I'm going to use next is triangle CBF. So there you will notice that D is a midpoint. It's given to me. DG is parallel to BF, right? That's also given to me. So I can say that G becomes the midpoint of what? CF. That means this GC is equals to GF, right? And what was GF earlier equals to? AF from here. This thing gave us what? AF is equals to GF. So we had three equal parts now. We can write AF is equals to GF is equals to GC, right? Combining these two results, I will write it as 1 and 2. Okay. So if you combine these, so I can very clearly see that I have divided AC into three equal parts. So if I pick one part out of it, it has to be 1/3 of the whole thing. So I can very conveniently write, therefore, AF is equals to 1/3 of AC. So I hope you have all understood these questions that we have talked about. By now, you have very easily understood that what you have to look for in a question that is related to midpoint and converse of midpoint theorem. You have to look for the correct way of the correct triangle. You have to look if it is one midpoint or two midpoints, and you have to look if there is a set of parallel lines mentioned in the question. Based on that, decide your midpoint or converse of midpoint theorem and then apply it in the question. I hope you have all understood the example questions. There will be more questions that will be uploaded on this topic, but for now, we will start with a new chapter as well. So practice well for your exams and keep me posted on your doubts. Thank you.